Well, we haven't done one of these for quite a while. So I'll use the definition that has h approaching 0, and then for the function square root of x, substitute x plus h, and then just the function with x in it. So this is basically rise over run. Alright, now we need to do some algebra. So if you can imagine these square roots not there, what would happen is we would have this, so it would be x minus x, those would be gone, and then the h's would cancel, and then we would no longer have division by 0. Well, in order to get rid of the square roots, multiply by the conjugate, the square root of x plus h, and then plus the square root of x. And that needs to be done on the numerator and denominator. Now for the denominator, don't actually multiply it out. So we'll have limit as h approaches 0, and then h times the conjugate. The reason for that is I want this h to cancel. Like I just said earlier, if we can get rid of those x's, then we can get the h to cancel. So just leave it right there. So hopefully we can cancel it in a bit. Then the good thing with conjugates is the middle terms cancel, so you only need what's the first one times the first one, and what's the last one times the last one. So the first one times the first one would be x plus h, and the radical would be eliminated. Likewise with this one, but it's a negative times a positive, so negative x. And then exactly what I was hoping would happen just happened. Now the x's cancel, and we just have h in the numerator. And we can now have h divide into h one time. So it's the limit as h approaches 0 over 1, and then for the denominator it's just the square root of x plus h and the square root of x. The good thing about this problem is I already know what the answer is supposed to be, 1 over 2 times the square root of x, and look at this. If you have h go to 0, that one's gone, and it's just the square root of x plus the square root of x. So that means there's 2 of them. And that is exactly what it was supposed to be.